both types of error in the Poisson distribution. So remember, type 1 error is rejecting H0 when it's true. The type 2 error is the other way around. So a very straightforward question. After a long period of time, it's known that there are 2 earthquakes per year. However, I think it's becoming more rare. So null and alternative hypothesis. Over 12 years, we stretch the Poisson distribution and count the earthquakes. So the probability of type 1 error is the probability of rejecting H0 when it is true. So there are 2 earthquakes per year. How many would we expect over a 12-year period? So this question is about rejection region or critical region and acceptance region. So the critical region or rejection region is every situation in which you would reject the null hypothesis. That's clearly what we're interested in, particularly when it's true. So I draw the Poisson distribution under the null hypothesis. It looks like this. And there is a region here where I would reject the null hypothesis. So let's say the question said the significance level is 5%. So 5%, these little bars here have to add up to less than 5%. Now, first of all, you see, it's very unlikely they'll add up to exactly 5%. So we're not looking at exactly 5. We're saying, what is the highest number that are less than 5? Well, we can easily do that. So the mean is 24. I'm not bothering to type an X. I'm just going to have a look at it. And I want this number to be 5%. And you have to be a bit careful here. Less than 16 earthquakes in a 24 Poisson, in other words, over 12 years, is 5.6%. I would write this down as working. And I'm going to go across and say, well, 16 is just a bit too big. 15 is 0.344. Therefore, the critical value is x equals 15. The critical region is x is less than or equal to 15. And the probability of a type 1 error is 3.44%. Really nice. Let's have a look at a type 2 error. So a type 2 error is the probability of being in the acceptance region when we find out some information that this is wrong. So the null hypothesis is wrong, but we accept it anyway. So what is the acceptance region? Well, if this is the rejection region, then the acceptance region is x is greater than or equal to 16. So we take that from this part of the question. We've worked out the critical region. So we know that the acceptance region is a crucially important thing in the next part of the question. So a probability of a type 2 error is the probability of accepting H0 when it is false. So I can recast that to say the probability of x being greater than 16 when the true mean is 1.5. In other words, the probability that x is greater than or equal to 16 when x is a Poisson of 12 times 1.5. We don't expect 18. What's the probability of being 16 or more? It's going to be fairly likely, isn't it? Let's do it on the calculator. So I have the old thing on the screen and I can visibly see the acceptance region. I want to be in there. So I want to be greater than or equal to 16. So I'll go back and I'm going to change this to a tail right. And I want to be 16 or more when the average is 18. 71% chance of that happening. So that's the probability of type 2 error.